Let me tell you the story of two brothers. Now they were the progeny of same parents. That brother became very strong-willed and very determined and became a great achiever. Same is the story of carbon. When carbon under very high temperature and pressure inside the earth's crust changed into diamond, and diamonds are forever. Very valuable, they have shining luster, they sparkle in light and they reflect light. They even reflect light. So they are really considered very valuable by kings, queens and even common people. On the contrary, there is another form of carbon, and that is grey in color. Not that it is not useful, it has some other qualities. Like you can say one brother was good in academics, other was good in the sports. So you see, in this case what happened? The other one had a smooth and slippery surface, and it was not very hard and rigid like diamond, and it was a good conductor of electricity. So we could use it in the batteries. And what is its second brother? Graphite. So what we find is that carbon is found in two physical forms, diamond and graphite. Diamond is hard and rigid, while graphite is smooth and slippery. High density, that is why it is hard and rigid. Low density. Sparkles, doesn't. Not a good conductor of electricity. Most of the non-metals are not good conductors of electricity. While this is good conductor. Now why this? Why two physical forms? Are they really different from each other? No, both are carbon and both have same chemical properties. You burn them, you will get carbon dioxide. So we have to understand what is this phenomenon and why this difference. This phenomenon or these two are called allotropes, and the phenomenon is called allotropism. Alright, we understand that diamond and graphite are allotropes, but why? The reason is their structure is different. In the case of diamond, one carbon atom is attached to 4 carbon atoms, which means if it is in the form of layers, 3 carbons are attached on the surface and 1 down below. So the result is there is a 3-dimensional structure, and that is why it is hard and. In the case of graphite, the 1 carbon atom is attached to 3. They are kind of hexagonal arrays stacked together, one above the other like this. But they are not connected in the layers. So they are just hexagonal, means when they have 6 branches. So they are hexagonal arrays placed one above the other. But just the layers. The layers are not interconnected. And now you can well understand why they are smooth and slippery, because this next connection is not there. But then the question arises, how are the 4 valencies or the 4 electrons satisfied? How is the carbon satisfied? 3 carbons will give 3. 1 has a double bond. So with 1 carbon there is sharing of 2 electrons, and that is how all the carbon atoms get satisfied. in the case of graphite also. And this is the reason for their properties, difference in their properties. Diamond is hard and rigid, graphite is soft, smooth, slippery, and diamond is a non-conductor while graphite is a good conductor of electricity. Recently, another form of carbon has also been found, and this is called C-60 Fullerenes. Don't miss this E's. There are three E's. E, R, E, N and E-S. Fullerene is the word. Now in this case, the substance is like a football, as if the carbon atoms are arranged on the surface like a football. Now why the name fullerenes? Because this structure resembles a dome called geodisc. Disc, you go for disc, discos you go, so remember from there. Geo means earth. So this geodisc dome, who designed it? There was an architect called Buckminsterfullerene. So the word fullerenes is from fuller. Now remember, it's minster, not minister. So I is not after N. There is a tendency to get confused about such spellings. So remember, it is Buckminsterfullerene. And on his name, this new form of carbon was